Hello again, this is Algebra 2, Unit 4, Section 6.3, Dividing Polynomials. This is Video 1. We're going to explore various methods of dividing polynomials, but let's remember we've been dividing polynomials for a while. Every time we factor something, technically we're dividing out factors and rewriting as a multiplication problem. So in a sense, factoring is a method of dividing polynomials. We're just going to look at two more methods. One is long division and one is called synthetic division. I hope you like the synthetic division version better by the end. But in order to understand where synthetic comes from, we have to handle long division first. So long division is a concept you've seen before. If I wanted to divide, let's just say the number 125 divided by the number 7, just for learning the vocab. 7 is the divisor, it's the number doing the dividing. 125 is called the dividend, it's the number that's being divided. So a long division problem looks something like this. 7 on the outside, 125 on the inside, and we wouldn't think of dividing all of 125 by 7. The beauty of long division is it breaks up the division into parts. So we would first think, what is 12 divided by 7? Or how many times does 7 go into 12 evenly at most, which would be once. So we would do 1 times 7. We would write that below the 12, which technically stands for 120 currently, if we thought about placeholders. But in essence, we're thinking about it like a 12. 12 minus 7 would give us 5. And we drop the next placeholder, the ones digit, and we start the process over again. So 7 times what would get us as close to 55 as possible. That'd be 7 times 7. 7 times 7 is 49. We would again continue the subtraction idea and start bringing down more numbers and continue to long divide a divisor out of a dividend. Well, same thing works for polynomials. So I have my divisor right here in x minus 5. I have my dividend in x squared plus 2x minus 30. So x squared plus 2x minus 30 is going inside, and x minus 5 goes on the outside. And just like the 125 divided by 7, I tried to divide parts of that number by 7. I'm going to kind of do the same thing here. So my first thought's going to be, what would I have to multiply x by to turn it into that first term, x squared? And that would just simply be an x. And last time we thought, how many times did 7 go into 12? That was 1. So then we took the 1 and multiplied it by the 7. Well, we're going to do the same thing here. We're going to take the x and multiply it by the divisor. And we're going to write that below the dividend. So x times x would give me x squared. And x times negative 5 would give me a negative 5x. And let's keep in mind that we subtracted values, and I think some people are going to find that instead of subtracting concepts, it's easier to add the opposite. You're more than welcome to subtract if you want to, but I like thinking about this as adding the opposite values. Therefore, I don't have to consider subtracting a negative number. So x squared plus a negative x squared is no x squareds, and 2x plus 5x would give me 7x. And then the next step, after we found 7 went into 12 once and we subtracted the 7 from 12, we got 5. We drop down that next number. Same concept holds true here. I'm going to drop down the constant, and now my process starts all over again. So x times what would give me 7x? Well, that'd be a positive 7. And then I would multiply this 7 right here by the divisor. So 7 times x would give me 7x. 7 times negative 5 would give me a negative 30. And I'm going to subtract these values, which is just like adding opposites. And I have 7x plus a negative 7x is no x's. And I have negative 30 plus 30 is no constants left over. So when I take x squared plus 2x minus 30 and I divide out in x minus 5, my result is x plus 7. Now this result actually tells us a lot. It first tells us that x plus 7, since we don't have a remainder, there was nothing that we couldn't divide out. That means x plus 7 is a factor of x squared plus 2x minus 30. It also means if we wanted to write this in factored form, one of the factors would be the divisor. The other factor would be our quotient. And quotient's just a fancy word of the answer to a division problem. So this guy right here, the x plus 7, is our quotient. If we had a remainder value left over, then we could say that x plus 7 is not a factor of the original polynomial. It does not divide into it evenly.